Hi, welcome back, Hononegah. Section 3.1, solving quadratic equations. There's 5 methods to solving a quadratic equation, and some of them are easier in certain methods, but we are going to learn about 3 of those today. So, quadratic equation with one variable is an equation that can be written in standard form, ax squared plus bx plus c, where a is not 0. The b and the c can technically be 0, but the a is not. You can use various methods to solve a quadratic equation. And again, there's really 5 methods to solving a quadratic. And so depending on what the quadratic looks like, depending on the method you would probably use. All right, so the first one, solve by graphing. So you're going to graph and look for the x-intercepts. The next one, solve by square roots. So if you happen to be in a form in which you have u squared equals d, or basically have just a squared term equaling a number, then you can solve using square roots. And the last one, the reason we did section 3.1 AC, is solve by factoring. So the 3 methods we're going to learn today, graphing, square roots, and factoring. So let's start with graphing. If we turn this into a y equals x squared plus 2x minus 8, I can graph that parabola. So I have to find the vertex. Negative b over 2a. This goes back to chapter 2. So negative b over 2a. I end up getting negative 1. Plug negative 1 back in. So if I plug negative 1 back in, I get negative 9. So I'm going to graph my parabola, negative 1, negative 9. I'm going to use the shortcut method. Those of you that watched the video on section 2.2, I believe it was, you go over 1, up a, over 2, 4a, over 3, 9a. So again, you can do an XY chart. There's nothing against doing an XY chart. And those would be the points that you would get using an XY chart. You could type this into a graphing calculator and use the table function. And again, it would give you these points to graph. Now, what we're looking for is the intercepts. The intercepts in this particular picture are at 2, 0 and negative 4, 0. The intercepts also give you the solutions. The solutions is where the intercepts occur. So x equaling 2 and x equaling negative 4 are the solutions for the intercepts at negative 4, 0 and positive 2, 0. So solve by graphing, we will turn any quadratic into a y equals equation and then graph the y equals equation. So next one, I need to first make this equal 0 then, so that I can turn this into a y equals equation. Negative b over 2a, so I end up getting 3. Plug 3 back in, I end up getting 3, 0. So 3, 0 is the vertex. Using the shortcut method, over 1 you go up or down, in this case up a, so I'll go up 2. 4a, so I go up 8. And then I graph the parabola. The only intercept is 3, 0. It's the vertex, so the only answer to this question is x equals 3. Before we get into solving quadratics by square roots, we first have to talk about simplifying square roots. So anytime you simplify, there's 2 ways of doing this. I'm always going to do it by the factor tree method, but I'm going to show you another method here as well. So the factor tree method says, I am going to break this down into its factors. So what I do is a tree with all the prime numbers at the bottom. So 2, 2, 2, 2, and 4. Or 2, 2, 2, 2, and 5. So I have a pair of 2's and a pair of 2's. Anytime you get a pair, it gets to come out of the radical, and anytime you have a single, it has to stay in the radical. So I have a 2 that gets to come out, a 2 that gets to come out, and a 5 that has to stay in. So this is 4 square roots of 5. Square root of 80 is equivalent to 4 square roots of 5. Now the book would tell you to do it this way. 80 is 16 times 5, and since 16 is a perfect square, you end up with 4 square roots of 5. So they break it down to its perfect roots. That gets a little bit more complicated because some of you probably didn't know that 80 was 16 times 5. So doing the factor tree allows you to break it down into its prime numbers. So I always do it by factor tree. So 2 times 27, 3 times 9, which is 3 times 3. Pair of 3's come out. The 2 and the 3 are both single, so I put them both back inside the radical, and so I take 2 times 3, which is 6. 72. 2 times 36, 2 times 18. Again, I'm breaking this down into its prime numbers. Pair of 3's, pair of 2's make 6 on the outside, 2 on the inside, but there was already a 7 out there, which makes 42. Square roots of 2. So don't forget about the coefficient out in front. After you have done your factor tree and actually you've done your simplifying of the radical, then multiply the outside value by the coefficient. All right, so where does that go? Or fractions is another one, and this one gets even more complicated. You can never have a radical in the bottom of a fraction. When a radicand in the denominator of a fraction is not a perfect square, you can multiply the fraction by the appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. All right, let's look at the example here. I have 2 square roots of 5. So what I do is I multiply both the top and the bottom by the square root of 5. The square root of 5 times the square root of 5 is just 5. And then 2 times the square root of 5 just stays that way. So here we go. Square root of 4 times the square root over the square root of 7. The square root of 4 is just 2. So I would multiply both the top and the bottom by the square root of 7 and get 2 square root of 7 over 7. Anytime you take a square root times itself, you will always eliminate the square root. So the next one, I have the square root of 5 or the square root of 4. The square root of 4 is already a perfect square, and so that's the answer, square root of 5 over 2. The last one's probably the most complicated. I'm going to multiply both the top and the bottom by the square root of 5. Square root of 8 times the square root of 5 is the square root of 40. However, the square root of 40 can be simplified because there's a pair. So it's 2 square roots of 10 on the top with a 5 on the bottom. Where does that go from here? I can, anytime I only have an x squared, I only have one term squared, I can use the square root property. Subtract 14 from both sides. So isolate the x squared. So I get 56, divide by 2, and take the square root of both sides. Now, here is one big rule that you're going to have to know every time you take the square root of both sides of an equation. You will always get a plus and minus answer. So taking the square root of both sides of an equation will get you a plus or minus answer. Now, the square root of 28, if I did a factor tree, has a pair in it. So the answer to this question is plus and minus 2 square roots of 7. You are going to get a bunch of points taken off on tests and quizzes if you don't have the positive and the negative 2 square roots of 7. Now, some of you might ask, why is that true? I'm going to go back to a very simple question to show you why that is true. X squared equals 9. If I took the square root of both sides, everybody in the room would probably say 3. But 3 and negative 3 work. 3 squared equals 9, and negative 3 squared also equals 9. So anytime you take the square root of both sides of any equation, you will always get a plus and a minus answer. So again, that is a very specific scenario. Okay, you have to be taking the square root of both sides of the equation in order to get a plus or minus. Do not do this. The square root of 4 does not equal plus and minus 2. The square root of 4 is 2. It's called the primary root. Now, if I had x squared equals 4, and I took the square root of both sides, then the answer to the equation is plus and minus 2. So please, hopefully you'll understand the difference between when should I do the plus and minus and when should I not do the plus and minus. Isolate 4x squared equals negative 4. Divide by 4. X squared equals negative 1. Take the square root of both sides. If you tried to do this in your calculator, you are probably going to get an error because that answer is not real. So there is no real solution. If you give me a couple of days here, we are actually going to learn to solve this. We are going to get what's called imaginary solutions. So if you take the square root of both sides and you are taking the square root of a negative, there's no real solution, but there are imaginary solutions. And again, we'll get into that in a couple of days. Now, I still have a single term. I can still take the square root of both sides and still get a plus or a minus. Now, this one's not a very friendly question, but I can split this into two questions then. Anytime I have a parenthesis and I'm taking the square root, I now need to break this down into the positive and the negative. Now, I need to rationalize. So x minus 2 equals, I'm going to multiply both top and bottom by the square root of 5. And then I'm going to add 2. So 2 plus the square root of 5 over 5. Next one, I'm going to rationalize. So I'm going to multiply both top and bottom by the square root of 5. And then I'm going to add 2. So I got a positive 2 and a minus square root of 5 over 5. This one, again, is not very friendly. I'm going to multiply by 4 to both sides. And then divide by 3. Take the square root of both sides. Anytime I take the square root of both sides, I get a plus minus answer, which means I'll split this into two questions, one for the plus and one for the minus. I'm going to move over here. X plus 1 equals positive square root of 40 over the square root of 3. X plus 1 equals negative square root of 40 over 3. Multiply both top and bottom by the square root of 3. So I end up with the square root of 120 over 3. 120 has a pair in it, so I need to rationalize it or simplify it. So I end up getting 4 square roots of 30 over 3, and then I would subtract 1. So there's one answer. This is negative 4 square roots of 30 over 3. I'm going to subtract 1 and get the other one. So again, neither one of those questions was very friendly there. But anytime you have a parenthesis being squared, I still can take the square root of both sides to get rid of the parenthesis. Last but not least, you can factor. So if something is factorable, you can use what's called the zero product property. The zero product property basically states if I have something times something else and it equals 0, then both of those items equaling 0 would be a solution. So think about it this way. If x was 5 and y is 0, it works. If x is 0 and y is 10, it works. So as long as x or y is 0, then this one works. And how we're going to use that particular property is we are going to factor it. So first, set it equal to 0. Factor, so factors of negative 48 would be positive 8 times a negative 6. That would get you the middle term. Now, once it is in factored form, set the parentheses equal to 0. So again, being able to factor something and then set the factors equal to 0 would allow you to solve. This gets more complicated because the number in front. I like the guess and check method. Not everybody does. One way to multiply to be 4x squared would be 4x times 1x. One way to multiply to be 3 would be negative 1 times negative 3. Check the inner and the outer. These two multiply to be negative 1x. These two multiply to be negative 12x. It adds up to the middle. So that is called the guess and check method. Now, set the parentheses equal to 0. So I get x to equal 3, add 1, x would equal 1/4. Your homework assignment is out of the book. You're going to be using 3 methods: solve by graphing, solve by square roots, and solve by factoring. Good luck. If you have any questions, make sure you talk to your teacher.